All right, now that I have all of my components that I want for this experiment into here, I want to make sure that they are going to sort correctly. And one thing I may have neglected to mention in the last video is that when I make changes to the HTML code, which, in this case I was changing the position that, this specific one, LENW AI93 sign slow, would jump to when it finishes. So that's this one here. It's going to jump to the end. When I make those changes to the HTML file and save it, it's basically automatically propagated to this JSON, to the JSON study, because this is linked to that same file. So once the file is updated, that new code is going to run. There aren't any cached versions or locally, you're not uploading anything here, so there's no locally saved file aside from the one on your computer. So that's exactly what these are referencing. Now, when you this is sort of the difference between working in your local JSON in your JSON server. Obviously, all the files here are local to my computer, and then once I have them uploaded, once I save this as a study, export it, and then upload it to the server version, I'm no longer able to go in and edit those HTML files because they're sort of wrapped up inside of that JSON experiment. I'm sure if you are a more sophisticated coder, you might be able to go into the JSON server and edit your HTML files kind of server side. I don't know how to do that, and it doesn't particularly seem like a safe way to do that, because if you make an error while that study is active or that component is active, it's just going to be an error that remains there online. So I always do all the editing locally, and that's sort of what's recommended, at least in the JSON reference documentation guides. So speaking of editing an HTML file, this one here, sort conditions, pretty desperately needs to be edited, because right now we have more conditions here that are not going to be sorted to. So first I'm going to look at this code. So here's my sort conditions file. It loads in the relevant scripts that are needed up here. There's some description, and then here is inside of the script portion the actual sorting function. So a participant comes into this study, and all of JSON's components are run in batches, and I'll be jumping back and forth between these two windows here. But the first thing that goes on here is this initiate batch conditions code, and this is referencing a function. The function is described here. So we can see what's happening. It's saying that, we're going to use JSON's batch session data to store which conditions are available. And if this is the first run, then it's going to initialize the batch session data from the component's JSON input. The way to reset the conditions is essentially deleting the batch session data. I'm going to explain what that means in just a second, but basically what's going on here is pretty typical code. You look at it's going to look at an array, which is going to be defined in the JSON input, and then it's going to generate a number of conditions based on the elements in that array. So I'm going to resize this window over here, and then I'm going to jump into my JSON file. So the first thing here is, where's that JSON input that's being referred to? Well, when we've gone into properties before, we've seen this input down here that says JSON input that we haven't really referenced previously. And as you can see right now, there's an array. It's being declared right here. So here's the name, here's the colon, and then here's what goes inside of this array. The array is called condition counts, and it currently has A and B, which are key value pairs, basically with, for condition A, the integer 100, for condition B, the integer 100. So what that is essentially saying is, inside of here, this is going to grab this array. It's going to grab everything in this JSON input, which is just this array here, and that goes, the variable condition counts basically fills up this array, gives it the information it needs. It says, okay, I need, for condition A, 100, 100A. So actually what happens is, when you create this new array called conditions, right, it's going to replicate the letter A 100 times. Then it's going to replicate the letter B 100 times. So you can see in my code here, I have a condition C for which I want actual, that I want to be, I want into my experiment, and that there aren't actually any information in the condition counts. This is the condition counts is what comes from this JSON input file in here. So I'm going to go into my jatos. This is one of the very few times when you actually sort of do any kind of code editing in the local jatos itself. And you can also do this on the server. You can change the JSON input on the server version. This doesn't have to be done in the local and then uploaded to the server. In fact, I think you have to do it on the server side as well. The JSON input is not saved across experiment versions when you export and then upload. So I'm basically adding in the condition counts for condition C, and you'll probably notice I have all these other ones commented out. So, originally I had this file set up to run illegal non-words version 1 and 2 for both illegal non-words, legal non-words, and pseudo-homophone. So that's 6 total conditions, the V1 and V2 of each of those 3 different non-words, non-word types. So I had these commented out because I was only running the first 2, and now I'm going to add those back in. So now we have 6 conditions here, and one thing about, or I guess, array structure, you don't want to comment on your last key value pair there, so it knows where the array ends. But as you can see in the last few videos, we have 12 conditions here. So I need to go ahead and add in these other conditions. But I want to show the next part of the code, as well as maybe circling back and referring to batches before this gets too confusing. So once we have this condition count, there's another function here. Here's where it fills up those, creates an array with all the required numbers for each specified letter or condition. Here's what those conditions actually mean. So for case A, it's going to randomly search through this big array. And for case A, I have a variable called next component position equals 4, right? So that next component position, as we saw previously, ends up getting fulfilled, supplied as a variable to this function, jatos start component by position. So this is where essentially after the next condition, here's a function for get next condition, which works up here, right? Ends up running. This is basically the last code that's gonna run in this script. The function is just defined below it, right? We can see this is actually at the end, and it's going to jump jatos to the next component in the position that was randomly selected. So for each of these values, A, B, and C, I have a different component variable. Number 4 refers to this one, illegal non-words version 1, AI 86% sign fast condition. So it's going to jump to here. And then correspondingly for B, it goes to 5. For C here, it goes to 6, and so on and so forth. So you can see I have these other ones that are commented out, and I'm going to add those back in as well. And this is the reason why I at least like having all of my components in this nice linear order. I could have them jump, I could have them in whatever random order, and then I would have to go in and change these component positions accordingly. It makes much more sense for me to have them all ordered normally in this case. So what I'm going to do now should be pretty obvious to anyone who's coded before. I'm just going to copy all of this here, and I am going to add that in and drop that back just a bit. So now I have 12 total conditions, and for the conditions, I'm going to, fill out these information in a very logical and I think straightforward way to understand, so that anyone who comes in to, maybe edit this code potentially after me will see this very sensible. Okay, the first experimental condition is number 4, that's A, and then B is 5, and then all the way down through the corresponding letters, we get the next ordered conditions here. So these are the ones that are going to be randomized between. So I'll finish up this bit of code here. So now I have my 12 total conditions. All of the numbers should line up, or actually, do I have more than 12 conditions? Because K should be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Where did I skip a number? 4, 5, 6. There it is. 7, 8, 9, 10. There we go. Okay, now that these are ordered correctly, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, the sort conditions would, randomize between these ones as needed for this experiment. So I need to also change this up here, where these need to now correspond to all of these letters, because this is going to be what fills out the values J and K inside of the batch conditions.